Here's a little more complicated exponential function. Y equals to 3 minus 2 raised to the x minus 1 power. So it's not a simple exponential function. There are some other things going on here, which render it a little more complicated than what I showed you in the previous video. Now you can learn how to analyze these things through what are called function transformations. If you take college algebra, you would study function transformations in some detail, and you might be able to apply that to a problem like this. For if you know what y equals 2 to the x is, then you can flush out what's going to happen with this graph. Okay, but you know, we don't have time to go into all those details in this course, so let's keep it simple here and just plot a few points. So I'm going to tell you, however, that the asymptote is going to be y equals to 3, because on either one side or the other, this term is going to go to 0. It's going to shrink to 0. It may be on the left, it may be on the right. I don't know yet, but when it shrinks to 0, then I'm left with 3. And so, in other words, the function will level off at 3 on one side of the graph. So I know that's going to be the horizontal asymptote, the horizontal line which the graph blends into. All right, but anyway, let's plot some points. We'll see that unfold here as we plug some numbers in. So how about we just start with 0, and y would be 3 minus 2 to the negative 1 power, which is 3 minus 1/2, so that's 2.5. If I go to 1, then I've got 3 minus 2 to the 0 power, 1 minus 1 is 0. And what is 2 to the 0? It's 1, so that's 3 minus 1, which is 2. If I plug in 2, I've got 3 minus 2 to the 2 minus 1, first power. That's 3 minus 2, which is 1. If I plug in 3, I've got 3 minus 2 to the second power, 3 minus 4, which is minus 1. If I plug in 4, I get 3 minus 2 to the third power, which is 3 minus 8, which is minus 5. So you can probably guess that this is going to start getting large in the negative direction. In fact, the next one will be what? It'll be 3 minus 16. It'll be negative 13. Let me go to negative 1 on the other side. This would be 3 minus 1 minus 1 is negative 2. So that's 3 minus 2 to the negative 2. 3 minus 1/4 is 2 3/4. And I think I can fit one more in here. If x is negative 2, I'm going to get 2 7/8. Okay, because that would be 3 minus 2 to the negative 3. 3 minus 1/8 is 2 7/8. All right, so all those can be readily computed, and I use 2 again because it's a pretty friendly number to work with exponential functions. You know, I think your textbook sometimes uses 3 or some other kind of number, and conceivably you might want to pull out a calculator on some of these and calculate these on a calculator. But I chose one that's not bad to deal with without a calculator. All right, so I hope you followed all these steps here, and I'm going to make some room by erasing much of it. So let's take off the right side of this. Okay, and let's see. My graph is going to looks like it's unlimited down below, but it's never going to go above 3 in the vertical direction. So let's see. Maybe I'll make a little more room on the bottom. 1, 2, 3. 1, 2, 3, 4, 5, 6. Okay, that'll probably do. And let's see, I floated between about negative 2 and positive 4, so I need to go out to 4 over here. By the way, when you draw me a graph, draw me a good-sized graph, all right? Don't give me a little tiny graph that I can barely read. Give me a good-sized graph. And because I have to grade them, and I'm wearing trifocals, and my eyes are getting old, and I don't want to squint. And besides, when you have a very tiny graph, you lose a lot of detail. Don't forget to put some numbers in also. All right, I need some numbers up there. so the reader knows what scale you're using. It makes sense in some of these graphing problems to use different scales, so I'll just kind of leave that at that. All right, so 0, 2.5. 0, 2.5 is right here. 1, 2. 2, 1. 3, -1. 4, -5. Down here, about. Going backwards, -1, 2 3/4, and 2 7/8. Like I said, we observed that the horizontal asymptote is y equals to 3. It is the horizontal asymptote. Because at one end of the graph, that part's going to go to 0, shrink down to nothing, I'll just be left with 3. So that happens to occur on the left side of the graph, so I'm going to try to draw it. That's not too bad. Okay. Make sure you don't go above your your asymptote on this problem. It's possible for graphs of some functions to cross their asymptotes, but not on most exponential functions. Do not do that. All right, so there's a graph, and it actually is. I guess I would call it an exponential growth function, but it's growing in the negative on the negative side. It's growing toward a large negative number rather than a large positive number. But anyway, there's that function there.